You've seen how to add and subtract polynomials. Like the integers, polynomials are closed under addition and subtraction. This means that the sum or difference of polynomials is another polynomial. What about multiplication? Do you think the same rules apply? In this video we'll look at how to multiply polynomials by other polynomials. This table shows different polynomial types that you can multiply. The simplest example of multiplying two polynomials is to multiply two monomials. Here's an example. We're multiplying two monomials, 2x and 3x squared. When you're multiplying monomials, multiply the numerical parts and the variable parts separately. Here you see two expressions. One is the product of the numbers, the other the product of the variables. The numerical product is straightforward, but when multiplying the variables, remember the laws of exponents. When multiplying x and x squared, since they have the same base, x, then add the exponents. The product is 6x cubed. Multiplying monomials is important because it's the basis for multiplying any polynomials, as you'll see. Let's look at multiplying a monomial and a binomial. This expression shows the product of a monomial, 2x, and a binomial, 3x minus 5. To multiply, turn this into a pair of monomial products. In other words, distribute the 2x to both terms, as you can see here. As we did with monomial multiplication, multiply the numerical parts and the variables separately, as you see here. The product then becomes 6x squared minus 10x. We can extend this idea by looking at the product of a monomial and a trinomial. Let's look at an example. As before, use the distributive property to distribute the monomial to all the terms of the trinomial. You'll see three monomial products. Simplify to find the polynomial product. Now let's look at the product of two binomials. We are going to multiply the binomial x plus 1 and binomial x plus 2. Each is a binomial because it has two terms. When multiplying binomials, you end up with four monomial products. Let's look at this step by step. First, multiply the first terms of each binomial. In this case we get x times x. Next, multiply the outside terms, or those terms that are next to the outer parentheses. In this case we get x times 2. Next, multiply the inside terms, or those terms that are next to the interior parentheses. In this case we get 1 times x. Finally, multiply the last terms, or the second term of each binomial. In this case we get 1 times 2. This method of multiplying binomials, multiplying the first, outside, inside, and last terms, is also called the FOIL method. The result, as you can see, is four monomial products. Do you see the four products? Now simplify each monomial product. We end up with x squared plus 2x plus x plus 2. You can further combine the linear terms to get the binomial product as x squared plus 3x plus 2. This method will work for any two binomials that you multiply. And in all cases you end up with four monomial products that you can simplify. Also notice that the product of two linear binomials is a quadratic polynomial. Finally, let's look at the products of binomials and trinomials or two trinomials. What we'll show you is a method that will work for either type. Here is the product of a binomial and a trinomial. We're going to use column addition to find the product. So, here is the product of x and the trinomial. Next, we see the product of 1 and the trinomial. Finally, combine the terms to see the polynomial product. This method will work with any polynomials. Using column addition allows you to keep track of all the terms to get to the final product. As with integers, polynomials are closed under multiplication. The product of two integers is another integer. The product of two polynomials is another polynomial. Now let's look at some examples of multiplying polynomials. This rectangle has length and width measures made up of linear binomials. To find the area of the rectangle, multiply the binomials, as shown here. Use the FOIL method to find the four monomial products. Then combine common terms to simplify. This is the area of the rectangle, which is another polynomial. Let's look at another example. This rectangular prism has the dimensions shown. To find the volume of this prism, multiply the three expressions, as shown here. The expression for volume is another polynomial.